So all of these terms, whenever you've got two terms, subtraction between them, perfect squares, they have a special title to them. They fall under their own category, and they are known as difference of squares. So this lesson is an introduction to factoring difference of squares. Now, we could still use the box method when it comes to factoring. I'm going to set it up. Because it is still a quadratic, I'm going to set up my 2 by 2 box. This term has got to be the x squared, the quadratic, and the constant is going to go here. But these two are my linear terms, but notice we don't have a linear term. We're missing the bx. So how is that going to happen? What are factors of negative 16 that adds to 0? And it's got to add to 0 because we don't have a bx. Well, whenever we set it up and we try to find our dimensions, x squared is still x and x. So factors of 16, 1 and 16, 2 and 8, 4 times 4. So what's going to be my only set that I can put together to make add to 0? Well, that's easy. 4 minus 4. So what has to happen? One of them's got to be a positive 4x, and the other one's going to be the negative 4x. And so then now I've got a negative 4 here and the positive 4 here. So I have my dimensions, x plus 4 and x minus 4. So let's take a look at the next one. So again, we set it up, 2 by 2 box. X squared goes here, negative 81 here, something x, something x. And so we set up our t-chart. Factors of negative 81. That adds to 0. So 1 and 81, 2 won't go into 81, 3 will. 3 and 27. Will 4 go into 81? No. 5 won't. 6 won't. 8 won't. 9 will though. 9 and 9. So what's going to be the only set that I can add together to get to 0? Well, looks like it's got to be the 9 and 9. So 9x here, 9x here, x, x, 9, 9, but we got to get to a negative 81, so one of them has to be the negative. So maybe that one could be my negative, and so negative 9x and 9x are going to add to 0. So now we've got our dimensions, x plus 9 and x minus 9. So maybe you're starting to notice and see a pattern. So let's take a look at the next one. So 4x squared here, negative 25 here, something x, something x. So for this one, when I set up my t-chart, remember, we still have to add to 0. But now we're going to multiply our outside. So 4 times negative 25 is negative 100. So factors of negative 100 that's going to add to 0, well, the only way that I'm going to get them to add to 0 and cancel each other out has to be a 10 times a 10. One of them's got to be a positive and one of them's got to be a negative. So negative 10, positive 10. So now let's go and look at GCFs. So what's the GCF of these two? a 2x. 2x times what is 4x squared? 2x. 2x times what is 10x? A 5. 2x times what is negative 10x? Negative 5. Maybe you're starting to notice something. Look at your factors. 2x plus 5 is a factor. 2x minus 5 is a factor. So I bet you can figure out the factors for this one without even having to use a box. If you notice, what is the square root of 4x squared? 2x. Because 2 times 2 times x is going to get me a 4x squared. And so the 2 comes out and the x comes out, leaving me with a 2x. What's the square root of 25? 5. So also notice how your factors are complete and total opposites of each other. If you remember back to multiplying, when your factors are opposites like this, they're called conjugates. So I bet one of them is going to be a positive, one of them is going to be a negative. So what is the square root of 9x squared? Well, the square root of 9 is 3. The square root of x squared is x. What's the square root of 4? The square root of 4 is 2. So I bet one of them has to be 3x plus 2, and the other one's going to be a 3x minus 2. So if you've not figured it out, well, hopefully you can see it now. Factoring without a box. Anytime we have a difference of squares, two terms, both of them are perfect squares, we can automatically set it up in this format. So a squared minus b squared would break down to a plus b as a factor and a minus b as a factor. So set up your factors, opposite factors. One is a plus and one is a minus, and take the square root of each term. Square root of x squared is x. The square root of 9 is 3. So x plus 3 and x minus 3 are my two factors. So what about the next one? Well, if you remember, x squared minus 1 is also a perfect square, so the square root of x squared is x. Remember, 1 has to be a positive, 1 has to be the negative. What's the square root of 1? 1. So x plus 1 and x minus 1. Well, what about the next one? 2x squared is not a perfect square, and neither is 2. But if you go back to your first rule of factoring and you look for a GCF, notice that both of these have a 2 in common. So if I factor out a 2, then notice I'm left with an x squared minus 1. Because 2 times x squared is 2x squared. 2 times 1 is negative 2. And then now notice how, with what I have left in my parentheses, how that follows into the difference of squares. And so I can factor that one down even further. So I'm still going to keep my 2, my GCF. I don't ever want to lose it. But then I'm going to set up my opposite factors. And the square root of x squared is x. The square root of 1 is 1. So x plus 1 is a factor, and x minus 1 is a factor. So 2, x plus 1, and x minus 1. Now, in this example, we don't have an x squared. We've got an x to the 4th. But if we notice, x to the 4th is also a perfect square because x squared times x squared is going to get me an x to the 4th. So I'm going to set it up, a plus and a minus, and then x squared plus 1 and x squared minus 1. Now, it's easy to say that we're finished, but we've actually can go one more step further, because notice how this factor is also a difference of squares. Now, x squared plus 1, that is as low as I can get it. I cannot factor that one down any further. But I can factor the second factor to an x plus a 1 and an x minus a 1. So in the x to the fourth minus 1, you actually have 3 factors. You have 2 difference of squares. So what about the last one? 45x squared minus 125. Well, again, we don't have perfect squares, but maybe we do have a GCF. So what goes into both 45 and 125? A 5. So before I begin, I want to factor out a 5. So 5 times what is 45x squared? 5 times 9x squared. 5 times what is 125? 5 times 25. And so then now notice inside my parentheses how I still have my difference in squares. So I'm going to factor them down further with my opposite factors or my conjugates. Don't forget the GCF that we factored out to begin with. The square root of 9x squared is a 3x. The square root of 25 is 5. So you have 3x plus 5 and 3x minus 5. So in this lesson, it's very important to know what your perfect squares are, because that way those perfect squares jump out and make it easier to identify this as being a difference of squares polynomial.